Okay, then there are some implications of the thin lens formula. So if you take a look at the magnification that we previously obtained, it is V over U. So you consider this thin lens formula and you ask what happens if U is equal to 2F. So if U is half of 1 over F, then V is, if U is 2F, then V is also 2F, because this term is half 1 over F and this term is half 1 over F. So their total is just 1 over F. So you see that if U is 2F and V is 2F, then the magnification is 1, right? Because the magnification is V over U. And then what happens if U is less than 2F? It's a fraction, so if you divide by a smaller number, it becomes bigger. So this other term has to become smaller. And it becomes smaller by dividing by a bigger term. So you see that if U is less than 2F, then V is more than 2F. So if V is more than 2F and U is less than 2F, then the magnification will be greater than 1. So in other words, if this object is moved closer than 2F, so here is F, maybe 2F is somewhere over here. If you move this object closer than 2F, then the magnification will be greater than 1. And also you can show similarly that if you move the object more than 2F away, then the image will be less than 2F away, and then it will be diminished. So this is the first key consequence. So the physics is interpreting the algebra in different cases. So there are 3 cases, right? If the object is less than 2F, then it's magnified. The closer the object gets to the lens, the bigger the image becomes. And the further the object is from the lens, the more diminished the image becomes. So that is the physical intuition behind the algebra's implications. And then there is a second interesting implication. If you look at this formula, previously we obtained this result. From this result that you get by similar triangles, you are able to isolate all terms that contain V. So you have VF and you have VU. You bring this term over, it becomes this result. Then you swap this part to the left and this part to the right. So it becomes U minus F instead of F minus U. Solving for V, you get UF over U minus F. So this expression for V, UF over U minus F, you can manipulate to obtain the magnification. So recall the magnification we showed just now is V over U, right? Magnification is V over U. So we take the magnification V over U, which we express as UF over U minus F quantity multiplied by U, and then we plot it in decimals, where we allow the x value to be the distance between the object and the lens. So that is the x term that we are plotting. So we have xf over x minus f multiplied by x. And for illustration, I just set the focal length to be equal to 16. So this part here is x equals 16, x equal f. And you notice that it's got a hyperbola. It's got 2 shapes, right? And you notice that this is the magnification. And you see that the magnification is always going to be greater than 1 up and until a position of u equals 2f. Remember that when u is equal to 2f, the magnification is 1. But for all other positions, right, it's magnified even when you take it from 0 up and until f. From 0 up and until f, u is less than 2f and magnification is more than 1. So it's got some implications. One of the implications is that if u is greater than f, it is magnified. And if you take note, the position of the image is for this particular range of u equals to f up to u equals to 2f, which is this part over here, u equals f up to u equals to 2f, is magnified, and you see that the image is located beyond 2f. So here's f, I don't know, here's 2f, and this is the image. So you see that the image is real, it's inverted, and it's magnified. And if you make it so that u is between 0 and f, if you take this object and you move it closer so that it's between 0 and f, right? Then you see that you come to this position here where you are still magnified, but your magnification is negative. And the reason why your magnification is negative, remember that magnification is v over u, right? And u in this case is x, is positive. So in order for magnification to be negative, it must be the case that v is negative. So what does that mean to say that this thing is negative? Well, it just means that it goes on this side of the x-axis. So in other words, if it's on this side of the x-axis, then what you get is a virtual upright and magnified image. Right? So in conclusion, we see that there is a relationship that's easy to remember from the thin lens formula. If you place the image, if you place the object u, if you locate that at 2f, then the image is located at 2f, and the magnification is 1. If the object is located less than 2f, then the image is more than 2f, and the magnification is more than 1. If the object is more than 2f, the image is less than 2f, the magnification is less than 1. So you can see that just by manipulating this formula. And then you see that as long as u is more than f, it will be real, magnified, and inverted. And if u is less than f, it will be magnified, virtual, and upright. So these are the results that you can remember. Commit this to memory, and for this one here, derive it as required just by inspecting the thin lens formula. So this tells you all of the cases that you otherwise would have to memorize, and then all you have to do now is just remember the applications. So I hope you found this useful. Thank you for watching.